Hi, welcome to Chem Camp. I'm Mrs. Newman, and I'd like to work a Thermo free response question to help you prepare for the May exam. This particular free response is just two parts, Part A and Part B. So this would be considered a short free response question, which your short free response questions will always appear on the latter half of your free response section. So let's learn a little chemistry. The problem reads, aluminum metal can be recycled from scrap metal by melting the metal to evaporate impurities. In Part A, they say calculate the amount of heat needed to purify 1 mole of Al originally at 298 Kelvin by melting it. The melting point of Al is 933 Kelvin, the molar heat capacity of Al is 24 joules per mole times Kelvin, and the heat of fusion of Al is 10.7 kilojoules per mole. So you have lots of information about aluminum here, but let's start with exactly what it is they're asking us to find. They're asking us to calculate the amount of heat. Now, heat is represented by the lowercase letter q here. Believe it or not, though, we're actually looking for total heat, because there's two processes going on here. The first process is heating the metal from 298 Kelvin to 933 Kelvin, and that's going to require a certain amount of heat. Then the second step is actually melting the metal, and that's going to require its own set of heat. They're also being a little bit tricky here because the formula on your AP Chem reference sheet is Q equals M times C times delta T, where M is mass in grams and C is specific heat capacity, which also is related to grams. Here, however, they're giving us moles and your molar heat capacity, which is related to moles. So we're going to adjust the equation ever so slightly. What we're going to do is Q equals N, the number of moles, times the molar heat capacity times delta T. So we're going to do 1 mole of aluminum times its molar heat capacity, the 24 joules per mole times Kelvin times delta T. Now, anytime you calculate delta T, you always want to do T final minus T initial. So we're going to do 933 minus 298 Kelvin. So if we plug this into our calculator, we are going to do 1 times 24 technically, times 933 minus 298. That gives us an answer of 15,240. However, we only have 2 sig figs in that molar heat capacity, so we're going to have to round our answer to 15,000 joules. Joules, because your moles are going to cancel, your kelvins are going to cancel, and you're left with the unit joule. Let's take a look at the heat required for melting. Now, when you're at the melting point, you're going to take the number of moles times the delta H of fusion. So we're going to do 1 mole again, because that's the number of moles of aluminum we have, times, this time, the 10.7 kilojoules per mole. Once again, our moles are going to cancel, and this time we're going to be left with 10.7 kilojoules. Now we're almost done, but we have to add the 2 quantities of heat together. However, one is in joules and one is in kilojoules. You can't add different units, so we're actually going to have to convert one. I always take joules to kilojoules, but you could always go the other way if you'd like. Keeping in mind that there's 1,000 joules for every 1 kilojoule, which means we're going to wind up with 15 kilojoules here. So now we can actually total our heat here. we're going to do the 15 kilojoules plus the 10.7 kilojoules, which should give us 25.7. However, since there's no decimal in the 15 kilojoules and we're doing addition here, we can have no decimal in our answer. So we're actually going to round it to 26 kilojoules. Now, in terms of points here, you will get a point for showing your calculation and getting the 15,000 joules. You will also get another point for adding the two quantities together. Again, you got to show your work and have units on your answers. Let's take a look at part B. Part B states that the equation for the overall process of extracting Al from Al2O3 is shown below, which requires less energy, recycling existing Al or extracting Al from Al2O3. Justify your answer with a calculation. So now they've introduced a new reaction or a new process and a delta H associated with that process. But they're expecting you to also pull down information from part A. In particular, you just calculated the amount of energy required to recycle 1 mole of Al, keeping in mind that it's just 1 mole. Here, in this chemical equation, now that's for the extraction of 2 moles of Al. So here, we actually have to calculate if we had 1 mole of Al, how many kilojoules that would require. But since we've got that balanced equation and the enthalpy associated with it, we can actually very easily convert between moles of Al and kilojoules, where, since according to that balanced chemical equation, I've got 2 moles of Al, and that requires 1,675 kilojoules of energy. So technically here, we're going to take the 1675 and divide it by 2, which gives us 837.5 kilojoules. So it requires 837.5 kilojoules of energy to extract 1 mole of Al, while it requires only 26 kilojoules of energy to recycle 1 mole of Al. Therefore, it requires less energy to recycle Al. So when they ask for a justification, you want to refer back to those values that you've calculated and compare both processes here. So for this part, you actually get 1 point for calculating the correct amount of energy for just 1 mole of Al, and you get 1 point for your answer with the proper comparison. So your short free response here will be out of total of 4 points. I hope this helps you prepare for the exam in May. Continue to follow along for more AP Chem content. See you soon!